So the triple beam started for me riding the Switchblade for a few years, and it gave me some ideas of a board that I really wanted to make. I figured out the shape I wanted pretty quickly, but figuring out the construction was a whole nother problem.
There's two main types of mold contours. You've got the top mount style where the concave continues all the way through the trucks, and then you've got this drop style where it has to flatten out a bit so the wood doesn't crack. The top mount is really nice because you've got these pressure points on your feet and your feet don't slide off. And then the drop is really nice because you've got the stops at the end so it keeps your feet from sliding off this way. The goal of this board was to combine those two features into one deck. It's really not that easy because you're limited by the materials you use. So if you take a stack of veneers, which is the way that most of our boards are pressed together, it's really easy to bend them in one direction at a time. But once you start to bend them in multiple directions, see how the paper actually creases, and that'll make everything crack and split. A lot of skateboard designs are limited by that manufacturing process. The whole idea with this board was to make a design based on exactly how we want it to feel rather than what materials we're using and the limitations that surround the project. This is where we started, just a big chunk of wood. We sculpted the surface of the deck based on Dillon's desires for concave, for W, for drop.
So I wanted a board that was extremely light with minimal flex. We brought the trucks in as far as we could to the drop to give it more control and stability at high speeds. Gave it a super small drop so you still have that on top of the board feel while still having your foot locked in like a drop board. Super mellow concave, giving you a really comfy feel, just enough to activate your turns. Threw some W on the back to keep the arch of your foot locked in for those heel side and toe side slides.
The drop is also curved. You get 3 points of contact between where your feet stand on the end and the corners of the board, so you get this really nice hug on your feet. We started to actually cut some blocks for the core of the board. It took about a day to CNC each side. You get something like this in the end after you cut out the shape. So there's the top surface, the bottom surface from an early prototype. After we cut this out, we experimented with different carbon inserts, 3D printed nose guards, wrapped it in all sorts of different composites, lots of carbon infusions. You want it to be stiff, but you don't want it to be rock hard. There's a bunch of boards that we made at first. They were really stiff, they were stable, but when you get to the bottom of a run, your feet would hurt from all the chatter, just from the stiffness of the board. So it took quite a bit to dial that in, and the problem was it took forever, right? It took a couple weeks to machine it and wrap it, and we couldn't really manufacture them in volumes. From this point on, we tried to make it a bit more manufacturable, make the process more reliable and more efficient, and that's where our composites expert came in to help out.
As you can imagine, when we're looking at different materials for creating one of these really high-end type boards, we're looking at several different types of resins, foams for the core, reinforcements, the different lamination schedules of those reinforcements, cure cycles. The number of combinations of these different materials is sort of limitless. So it took quite a few iterations and lots of rider feedback to really narrow down what was working for us. In the end, there's a couple of very unique features that we were able to develop for this board. One of them being this internal skeleton that goes into each core. So we have these composite stringers. This internal skeleton really transfers the load in the board as you're coming down the hill. We're casting this foam core around this internal skeleton. By doing that casting, it allows us to achieve that really complex geometry that we were looking for. And this also allows us to insert different stringers and orientations in order to really tune the performance characteristics. Another really unique thing that we developed for this board was a syntactic foam in order to encase all this. We're using a carbon wrap, and the composite layup on the exterior also allows us to do localized reinforcements so we can get the strength where we need it, but also keep the weight down. You know, you can start to see the really complex geometry on the bottom of the board as well, and this makes things quite difficult as far as molding and finishing go. Each one of these boards is built here by hand, all the way from the hand layup in the mold to all the sanding and finishing work. So another neat thing about casting these cores for this board is we're able to add urethane end bumpers here, and you can see that it's not exposed right now. Once we put it within the core and wrap it in the carbon, we're able to cut the material away and expose that urethane. The other kind of cool feature is that we were able to include the wood in here for mounting the trucks. It was done in order to help with some of the vibration management for riding rougher roads out there. There's a lot of things that we learned along the way of doing this. It's interesting to kind of see where this technology that we're working with is going to kind of lend itself to other projects in the future.
Yeah, for me, it's the best downhill freeride race board there is. Lots of stability, lots of control. You always know where your feet are. Super stoked for it to get underneath some other people's feet. I know they're gonna like it as much as I do.